And once again, welcome to this fifth or sixth class. Which class?
Fifth.
Fifth
Fifth.
class on fifth class on coordination compounds, inorganic complexes. We are seeing different types of ligands, their classifications. We have seen the nomenclature by IUPAC system. We have seen also the 18 electron rule, which is same as almost same as EAN rule, and how it is very rigidly applicable for carbonyls, metal carbonyls. 18, as Krishna was asking, for metal carbonyls, it is exactly 18. But less than 18 has been taken nowadays to, to at least to save the face of 18 electron rule, which originally was 18 electron. That was failed by thousands of inorganic complexes, stable inorganic complexes. Therefore, less than came, which accommodated majority of stable complexes. So we are joined in the Zoom by several guys like Girija, Amlan, Dibaranjan, Krishna, RS, Udit, and many others will be joining soon. Let me share my screen. And disable your annotation. And let me open a page. A new page. So after you leave about two sides, two pages, then let us make a table. Make a table. We are starting geometrical isomerism. We have not finished yet. And octahedral complexes with coordination number 6. That to be continued. And you leave about two pages. Very, very liberally leave two pages and make a table, an extended whole page table, whole page. Heading will be octahedral complex. First, formula. Formula type. And the next column will be number of GIs. GIs means galvanized pipe. Oh, I'm sorry. Geometrical isomers, which are really diastereomers. Number of enantiomeric pairs. Total number of stereoisomers. We shall not include the very simple square planar complexes here, because square planar complexes usually we will today study the exceptional cases where square planar complexes also show optical isomerism, DL pair, enantiotropism. But these cases are extremely rare for the point of view of your examination. But octahedral complexes are very, very important. M, A4, B2. Tell me, or same as M, A2, B4, same. Uh, Small letters, as I told you, represent monodentate ligands, and capital letters, at least two should be there together to represent bidentate ligand. That is the assumption we have taken. So tell me, how many geometrical isomers you have? Yes, anyone? Just
Two.
snatch away the microphone and energize the others who are attending my classes. Miss Nikki, good morning to you. Good morning to all of you. And those who are watching now slowly and steadily, just like I'm reminded of my childhood days when I was a small boy. I used to visit to Ramlila, as we call Jatra in India. That happens starts from night 11 and continues till early morning 4 o'clock, 5 o'clock it finishes. So my grandparents, there were three grandparents, original, his brother, his brother. They used to go to watch the Jatra in the whole night. So they used to take me. I was fond of this fine art, Jatra, Ramlila. Tur, 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 hatya. At that time, we were really very scared and excited as if a real war is being waged. So we find that when at 11 o'clock, sometimes we go, hardly two, three, four persons will be sitting. And the artists, they also know the people will come maybe after 1 hour, 12, 1. The people start coming, aggregating. Then the artists feel really encouraged, excited to perform their talents, I mean, to display their talents. So that happens, as time proceeds, 1 o'clock, then many guys they join, and you don't get any space to sit if we are because we get chairs to sit and watch. Jatra. The same happens, and when I start the class in the beginning, very few guys join, but towards the end, many guys they participate. But we will not slow down. I will have the same energy as I start after 1 hour or after maybe 2 hours. Now, tell me how many geometrical isomers you have?
Two.
Two.
Cis and trans. Cis and trans. And the number of enantiomeric pairs?
Zero. Zero.
Put a line. Then we have studied MA4 BC. Same. How many?
Two. Zero.
Then M A3 B3. Tell
Two.
me.
Zero.
2. What is the name? Is it the same as many people
Axial
call
and
this?
Meridonian.
Yes. Most people say same cis and trans, but okay, we will not dishonor them, let them say, but we say fac and mer. We will only write the cases where we are supposed to say fac mer, facial meridional. Otherwise, cis and trans. And what about this? Is any
Zero.
one of them a fit candidate for being chiral, symmetric, showing an enantiomeric isomerism? Yes or no?
No.
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 So
No.
0, 2. Put a line. We shall list all those which we have studied so far. Then what we have studied? M,
MA3 B2C.
yes, MA3 B2C. So
3. One
number
facial, two meridional.
one fact, two mer. Let us do facial. Welcome Satyajit. Better late than never. Um, and what about enantiotropism? Does it show any one of them shows optical isomerism?
No, sir. Zero. No, sir.
Then comes the most important MA3 BCD. Tell me
4 out of which one is sac and 3 are mer.
one fact plus 3 mer. So does any one of them is disymmetric and show optical isomerism?
Yes, sir. One.
One.
Fact.
Which one? Fact.
Sac.
So we add one. One is included in this number. So the total number of stereoisomers is how much?
5.
5.
5.
Then we start from today. Come back to a new page. Come back to a new page. I mean previous page. I am also leaving some space here. So we'll be back every time. Then we study which number? Number is 6, right?
Yes, sir.
M. We are now going to use bidentate ligand having identical donor like ethylene diamine type AA2A2. AA, you know, example is EN type. What is EN? What is EN?
ethylene diamine.
Welcome, Prabhat. Sorry, Prabhat is missing for the last several years. I'm sorry, he is missing. Prabhat. Okay, ethylene diamine type. So this will have two GIs, cis and trans, and the cis isomer is disymmetric. Let us draw. Drawing will not be important for examination purpose unless you are attempting a subjective question. But once you draw, you get a clear knowledge about all this. First, you have to draw this skeleton of octahedron. As I have told you, the bidentate ligand, the two donor atoms cannot go, you cannot write like this, or you cannot write like this. It's theoretically not possible. You cannot write like this. Not possible. So they have to remain close to each other, means cis to each other, means at an angle of 90 degree. So if we take, we can draw in many ways. For example, like this, En. We will not write NS2, CS2, CS2, NS2. En matlab it is ethylene diamine. And put here, we can say AA, no doubt, because sometimes we need to study the symmetry of the molecule. So let us write down AA. Instead of writing En, there can be oxalato also, another example. So let us rub it off. En, let us not write. AA, identical donor, and it's a bidentate ligand. It forms a, you know, if it is ethylene diamine, then 1, 2, 3, 4, 5-membered ring, a chelate. This is a bischelate. As many number of rings are produced by the use of polydentate ligands. Each bidentate ligand will form a 5-membered ring, what we call a bischelate. If it is a tridentate ring, one tridentate ligand, which is called a chelating ligand, will form 2 rings at a time. We'll talk about that later. And the other small a to occupy the adjacent position. This is cis. This is same as, I'm just, because you want to gain confidence in this, if you can also write whatever occurs to you. You can write AA here also, AA here also. Same thing. They are not superimposable. I mean, they are superimposable. Sorry, they are not superimposable. This is the mirror image. The cis is so this exists as a DL pair. You might be thinking, you might be definitely thinking, it looks like as if there is a plane of symmetry. No, no, no. Just remember, here this is a square. Just remember, this is a square. This is up, this is down. And from the up, you are going to one corner. And from the down, you are going to the other corner. Up this corner, down this corner. So you will not have a plane of symmetry. It looks like as if it is symmetrical, but you can yourself visualize that this A, this A, A, this A, that will never ever have any plane of symmetry or a point of symmetry or SN, alternating axis of symmetry. This molecule is dissymmetric. You can yourself at home, leisurely, if you are very interested, you can make a square type of model and make octahedral model and bind the two cis heads with uh, some uh, curve things and the other one like that, so that this a remains cis to each other. You will not find any element of symmetry. You may find Cn, a simple axis of rotation, but not these three, so it is asymmetric. But the trans, you can write in different way, but it has no symmetry element. It is uh, it it is symmetrical. It has all symmetry elements, at least one. So do draw. When you draw trans, either you can do here or there. I can draw two ways. And the small a will remain opposite to each other. So this is trans, and it has got a point of symmetry, a inversion center, so that this molecule is at symmetrical, achiral. Whether you write this or you write the the trans like this. AA this side. This is same. They are superimposable. AA. Same trans. Write down in a round box. It's not to be counted. So let us come to the box without further delay. And the example we can give, cobalt is the best example. En whole 2 and this is Cl2. This is dichlorido bis-ethylene diamine cobalt 3 ion. This is AA2 A2 type that will show symmetrical as well as optical. What shall we write here? Right? Oh my God. Okay. Sorry. We write MAA whole 2 A2 type. And how many? How many geometrical isomers?
Two.
What? 2.
4.
4.
2.
Only 2. Out of which one is optically active. It is chiral, dissymmetric. That is the cis. So we add one extra. So the total number of stereoisomers is 3. I do not have space. What to do? Okay. As and when it comes, I will write there. But your table is separate, waiting for you to fill up. Now we go to the next one. This is 6. There's 7. Similar type. MAA whole 2 AB. Same. Similar to MAA whole 2 A2. Cis and trans. Cis remains DL pair. Cis when A and B, cis. Trans when A and B, trans. In that, AA was cis, AA was trans. But the other diagram, capital A, will be the same as we have drawn before. But the only change that we'll be making, in place of small a, we will write a, small b. So let us not waste our time. This is trans. This is AB trans. Right? So the example that we can give, we can formulate of our own is this is chlorido bis-ethylene diamine nitrito N cobalt 3. Now, guys, a guy like with Sahu, he is retired hot. He is totally retired hot. Sometimes Sai is showing his presence, but Nihar has already retired. कोई बात नहीं. You know, it is the one who can understand the quality of the gold. He will be interested. He will never ever leave the gold. I mean, we have a proverb in Odia that is सुना को चिन्हे बणिया आ गुटे कौन कैन एनीवन फिल अप
गुण चिन्ह गुणिया
हाँ गुण चिन्हे गुणिया एंड
हाँ सुना चिन्ह बणिया गुण चिन्ह गुणिया एटा तो कोन
सुना चिन्हे बणिया सो तमे जदी ठीक बणिया नुह हाउ कैन यू the 24 karat gold or 22 karat gold or even that is gold, it will be appearing as if it is silver or even inferior metal. Anyway,
sir sir पूर्वटर ट्रांस रे प्लेन ऑफ सिमेट्री तो नहीं खाली सेंटर अछि ना इन्वर्जन सेंटर
yeah, center of inversion anyone SN जदि I and sigma, what would have been absent if Sn is present, that also make it a chiral, right?
Yes.
Then we go to 8. 8 is little different. It is M, only one such bidentate ligand, then A2B2. This will show 3, 1 cis and 2 trans. And the cis exists as a DL pair. It's dissymmetric. So every time I will not draw the mirror image. It is understood. We will not waste our time. Just I am drawing how it looks like. AA. Anywhere you can draw. You can draw AA here because the bidentate ligand, the two donors have to occupy a cis position, not any trans position, which is sterically impossible. Then we have in cis, AA will remain close, then BB will remain close. AA will remain close, BB will remain close. So that is the cis. It doesn't have any element of symmetry. And I will not, I'm leaving it here, making it apparent that this exists as a DL pair. And the other two, like we can draw quickly. Welcome those who are watching directly from the YouTube now at such an early morning. It is 5:28 India. And in here, where I'm staying in San Diego, the east part of US, it is just 4:58 afternoon. Now, keeping this bidentate ligand fixed, just for fun, you can play, you can keep bidentate ligand here also fixed. We can, in one case, we can put AA trans and BB have to come cis. So that is one trans 1. And you will find this is symmetrical. It is Octahedral. Let us not waste our time. Either you get a plane of symmetry or center of symmetry. Then you can make BB opposite AA come close so that you get two non-superimposable trans isomers. These two transforms are not superimposable. So total stereoisomers, how much? Oh, we have to write
4.
in that. Write down in that table M, AA, A2, B2. In here, 3, second column. Number of diastereomers or GIs, geometrical isomers is 3, 1 cis plus 2 trans, and this cis, this 3 plus 1 is equal to 4. Plus 1, I'm sorry, 1. I'm sorry, plus 1, this is the cis, the only cis, and the total is 4. The example that we can give is say cobalt En Cl2 NO2 whole 2. Anything we can think of. Oh, I'm sorry. This is -1. Cobalt hardly exceeds +3. So this is -2. This is -2. So cobalt, if it is +3, then I will make it -1. The name of this, who can tell me what is the name of this ion? Tell me.
Ethylene diamine, dichlorido, dinitro, cobalt,
Dinitro, that means you are in 19th century.
dinitrato, and
Ah,
cobalted
then
3
cobaltet 3. It is a negative ion. Dichlorido, C is alphabetically senior dichlorido, or you can call 19th century people call dichloro, ethylene diamine, dinitrito N. 19th century people call dinitro and cobalt tet. 3. Okay, we'll go to the next category, that is 9.
सर
Yes.
सर ଏଇଥିରେ ଯୋଉ ରେ ଉପରେ ଯୋଉ ଟା କରିଛନ୍ତି ତ ସେଇଥିରେ ଏ ଟାକୁ ରେ କହିବେ ନା ସେଟା ଟ୍ରାନ୍ସ ରେ କହିବା ଏ ଯୋଉ
Which one?
ହଁ सर ଏଇ ରେ सर स्मॉल ए
Oh,
जो
write down
पोजीशन ଅଛି
cis.
ତାକୁ
Write down cis. Only one cis. I have not written cis. Cis D, cis L, or cis plus, cis minus. I am not drawing the mirror image. I don't have time. You also should not have that time to draw. Your question, please, Chris. Chris, your
सर
question. What?
କ୍ୟାପିଟାଲ ତ କ୍ୟାପିଟାଲ ତ ପାଖାପାଖି ଅଛନ୍ତି ସେଟା ସିସ୍ କହିବା ସିସ୍ ପୋଜିସନ ତ
No, no, no.
ସ୍ମଲ କଣ ଆମେ ସିସ୍ କହିପାରିବା
Forget about bidentate ligand. Bidentate ligand, dekho. I am showing you, don't draw. You can keep AA here also. Here also, anywhere you have to keep bidentate ligand. Then see whether AA are close. If you keep AA here, then you are drawing trans. But I am interested to draw cis. So you have to arrange, supposing B here, AA here, or the vice versa, B here, or AA here. I hope you understand.
yes sir
So this is same. This is one, this is the other drawing. They are superimposable, cis. But its mirror image will be non-superimposable. But this one is same as, of course, I don't know whether this will be its mirror image. We have to take the two models and place before each other by rotating your hand to realize whether this is mirror image or really superimposable. This could be its mirror image or superimposable, that I cannot say, but it represents the same diastereoisomer or geometrical isomer cis. Understand?
yes
Any other question you have?
ତ ଆଉ ଗୋଟେ sir ଯଦି
Yes.
angle ଟା 90 degree ଥିବ ଦିଟାକୁ ମଝିରେ ତାହେଲେ ଆମେ ସିସ୍ କହିପାରିବାନି ସେଇ ଦିଟା
Cis, this you consider the monodentate ligands. The bidentate ligand, you have already fixed them. The two donor atoms have to occupy any two cis position, this or this or this or this or this or this. Understand? Not this, not this, not this. After having fixed the bidentate ligands, supposing earlier we saw AA2, capital AA2, small a2, or AB. There, for cis, we have to keep the two bidentate ligands close to each other, so that the other monodentate ligand would come close to each other. But if you keep the two opposite to each other, the two donors are cis. But if you keep the two bidentate ligands opposite to each other, then you have to draw the monodentate ligands opposite to each other. But wherever you write, whether this opposite or this opposite, is left to you. You understand?
yes
Okay, we are going now to the ninth type. The ninth type will be similar. This is MAA. Instead of A2, B2, we'll just make a different monodentate ligand C, but with coordination number 6. So here we have 4, out of which cis will be 2, non-superimposable 2, and each exists as a DL pair, and trans 2, which are some people call mesoforms. Well, if it is inactive, it is meso. But it is better to say inactive. They're achiral. Is there is a different way to find out the configuration, absolute configuration of complexes. Maybe when I will indulge in some kind of luxury, I will tell you, there are 4 ligands and the axis will be taken as the direction of our viewing. Then we have to assign whether it is anti-clockwise or clockwise. We have a different way to assign the absolute configuration of the complexes. But doesn't matter. The relative configuration is if one is plus dextrorotatory or small d, the other one is minus levorotatory or minus. Okay. Then let us draw to convince ourselves. Let us draw what are the two cis. Supposing we fix this bidentate ligand here, this AA and BC should be close to each other at the cis position. AA cis, BC cis. This is one cis one. The other one, you can supposing you switch between C and B. What you will find, I'll tell you. AA, let us keep it here, but switch between C and B. Do not change the bidentate ligands. Here, A and C are opposite. We are saying cis because AA are opposite. AA are opposite and BC, AA are cis, BC are cis. That is why we are telling cis. Here also same. AA are cis, so also BC are cis. But here A and B are opposite. Here A and C are opposite. So they are not superimposable. The two are non-superimposable but cis. And each is chiral, dissymmetric. This is cis1, this is cis2, this is chiral, this is chiral. I am not drawing the mirror image enantiomers that is understood, chiral. But the two trans don't take away the bidentate ligand. In this case, at least one pair should be opposite. Supposing we keep AA opposite. So in that case, BC will be undoubtedly coming close. And the other case, we shall keep BC opposite. So in that case, undoubtedly AA will come nearer. So you can visualize each of them is achiral, symmetric. They are optically inactive. These trans 1 and trans 2. These are all achiral. So let us go to that table. I don't have a table now here. MAA A2BC type, the formula, and the number of GIs, what shall I write with it?
4.
4. 2 cis plus 2 trans. And what shall I write in the number of enantiomeric pairs?
2.
2. Only the 2 cis, each cis. And the total is how much? 6. Put a line. So such kind you can give an example here, not in the table. Not in the table, give an example here. Cobalt, ethylene diamine, Cl2, aqua, say amine. Whatever you, and this is plus. Because amine is a neutral ligand, aqua is a neutral ligand, ethylene diamine is a neutral ligand, but dichloride is -2. This has to be +3. Supposing it is +3, so the net charge of the complex is +1. How are you feeling, guys? Those who are watching, the number is increasing. Give me some chart. I mean, not chart that we eat in India, but write some few lines in the chat box if you are really watching, and motivate me. I was really thinking today. I was a little disheartened. Our organization, what we call the uranium works mostly for the schools level students, class 9, 10, 11, 12. 9, 10 for Odia medium, vernacular medium in Odisha, but 11, 12 all global. Odisha, we deliberately choose to talk in English, Indian English, but that English should be, according to us, should not be delivered in a way that the native speakers can never ever understand, or those who have learned good English. Good means having some similarity or more similarity with British accents or US accents. British accent is most authentic because the English language originated from Britain, Great Britain. So otherwise, if you pronounce an English word in a very defective way, you may not say very. Here, R is pronounced as R, very. Any R, even R is R, not R. You can say very. If you say very, very, it is okay. But you should not say train, wait, or some very typical pronunciation which is uh, mostly a regional basis. Regional flavor is there. South Indian flavor, a North Indian flavor. So that should not be there so that you are understandable. If you talk slow, even an American guy, a British guy can understand what you are speaking if you are talking slow. Okay, Krishna, do you have anything to ask in your mind and to slow down the process? You can do so.
No, sir.
So we are extending the table. Let's see how far we can go. This is M. This is point number 10.
10.
M, A, A3B. Same. Bidentate ligand 1 is continuing. But A3B, here the number will be small, only 2. FACMAR. Some people call cis plus MAR. And none of is dissymmetric or chiral. How to draw FACMAR? I have told you that these three guys, monodentate guys, are important. These guys are important. They will remain in such a manner that the triangle that you form, the triangular plane, will not pass through the central metal atom. And once it is a bidentate ligand, have a habit of drawing anywhere you like, and you continue that habit. Supposing you have a habit of writing A here or there, whatever. And if this A is written this manner, so that this triangle, if you have a triangle that is not passing through the central, this is what we call the the facial. Let's go and make facial. And the B will be here. So this will be fact isomer. And if you make a switch between the small letters, that means monodentate ligand, you will get MER. If you make a switch between this, any two, between A and B, bring A, not between this, in a manner that you will get a triangle passing through. That you have to ensure that you are really getting MER. MER means that A, that plane will be passing through the metal. So A, now here A, So this AAA triangle is passing through the metal. This is mer isomer, and the bidentate ligand is the same, the mer isomer, and each you will discover some element of symmetry to make it a chiral. So what table will be doing? In the table, go back to the table that you are drawing. Let after 2 pages you are drawing a table. Guys who are watching from the directly from the YouTube, you have to make a table. That guys who have joined in the beginning, they have already made after 2 pages, and we are adding it. Formula type, the number of geometrical isomers or diastereomers, then the number of enantiomeric pairs, the total number of stereoisomers. So here you M, AA, A3B, that is the formula, and here this is 2, FACMER, here 0, and here 2. Got it? Then
Yes,
we
sir.
go for 11th, M, AB whole 3. What is AB? Who can tell me capital AB? Like glycinato,
ତା
bidentate
ପୂର୍ବଟା
ligand
ଏକା
having two.
chiral କାଇଁ?
Huh?
ସାର୍ ଏ ପୂର୍ବଟା chiral କାହିଁକି?
You have gone mad. I think let us go together. I have a, I have been telling time and again that I have a ex-student who is now a very coveted professor of psychiatry in AIMS Bhubaneswar. So let us all go together to Professor Vishwa, who will be very glad to treat us. I've told you that you discover some element of symmetry, you will definitely find one, in all the cases, either I or sigma. So he wants to spend more time on this to discover where sigma goes or where I goes. I have no hesitation. You have to attend many more classes on this. Here, the tell me where the element of symmetry will pass.
Sir, A B जो line
Hmm?
Sir, A and B line था vertically opposed.
sir A और B line pack रे
Huh? A and B, this line.
ये sir pack रे A और B line
Yes. Now, Thackeray AB line? I don't think so. AB line, this is not the mirror image of this. This is not the mirror image of this.
sir माने A B line टा ଯିବ small a जो दिटा ଅଛି equatorial रे तांको मझिरु
Once again, tell me. It will
sir
carry A
but
and B. That plane will carry this A and B. And
yes sir
what more? What more?
sir sir small a ଆଉ small a दिटा भितरु पास मझिरु पास करियो
Like this here.
yes sir
Yes. A plane, if that is the plane, how it can accommodate A and B? This A, B. If you have a plane like this, or plane like this is a plane here, how can it bisect? Yes? Anyone? That's what he is asking. He's saying that for this, it is understandable. Tell me where this is going.
sir
Hmm. Hmm.
ସେ ଆଉଥରେ ଟିକେ କହିବେ।
No. You have to point out where is the plane of symmetry or I or any sigma going here. Fact. And then we will talk more. If you want to tell about more first, then say. Hmm?
सर मर कैपिटल है और स्मॉल भी ଦେଇକି ଯାଇପାରିବ
More is very simple.
ସେ
Because
ମୋର
the
ଯୋଉ ସ୍କୋୟାର ଟା ଅଛି
square plane itself is the mirror plane, where these capital A, small b, they are lying on the same plane. But this is the mirror image of this. So those atoms which are sitting on the plane, they are themselves the object, and they are the mirror images. That is okay. But this is really little tricky to find out where is the element of symmetry passing through it. If it is not, then we have to make +1. Now see here.
ଏବିଟା ଟ୍ରାନ୍ସଭର୍ସ ପାସ୍ କରିଥିଲେ ହେଇପାରିବନି
What?
sir transversely means
Yeah.
dissecting the A and
A and
ମାନେ small ଆଉ capital A ତାଙ୍କ ଭିତରେ ଯୋଉ ଲାଇନ ଟା ଅଛି ତାକୁ dissect କରିବ
undoubtedly the plane, if it is a plane, that should contain this A and B. But if it goes like this, then the two sides are not mirror images. That's why you have to find some other directions where you think of. So this is given a home task to you. You tell me next time, if really you get a plane of symmetry, you just perform it in a model and find out whether it has a I or sigma, or if both fail, there is Sn. If nothing is there, you say that no, this has to be chiral, you add 1. So this pack isomer remains as a DL pair. So that modification or correction we will make, but I will give this as a task without wasting more time here to struggle our brain. We go to MAB3 type. And what is capital AB?
Bidentate ligand having different
Donor atoms like glycinato. Now, this has also ZIs 2, FAC and MER, and each exists as a DL pair. We can draw this there will be 3 AB whole 3. AB should be, supposing we want to draw FACMER. Let me first draw AAA. To make AAA triangle, bypassing the metline, going out of the plane of the metline, and BB also will go out of the plane So that will be the FAC isomer. You see A, that triangle is not touching the metal ion. That's not going through the metal ion. So also B. So this is facial. And if you make any one switch among them, anyone, supposing I will make it BA here, and rest remain same. Don't switch all. Only one switch will make A will now be remaining mer. B will also remain mer. So this is mer. Some people call trans. So this is disymmetric. This is disymmetric. Please do not ask me to just kill your valuable time, because you are not able to give me sufficient time, and therefore I am little speedier. And if I, I had not thought about this model, to view the model whether I is there or sigma is there, but I was almost convinced that A3 is there, so it cannot be disymmetric. But still, since we have not yet finalized this, we will work on this and come with our final solution next time. But don't put me here to do the same thing and spend to show you where is I, where is there is no I, no aja, no nothing, sigma. And there can be a Cn, but there is no sigma, no I, no Sn. So they are all, and each is DL pair. Right? Then let us add in this table, that same table, that M AB3 type, and this is 2 facmer plus 2. Both exist as a DL pair, so total is 4. Total is 4. Then we go to the next type, that is 12. This will be, again, we'll come back to monodentate ligand, M, A2, B2, C2 type. The example that we can give in the previous case is cobalt tris-glycinato or triglycinato, doesn't matter. This is a neutral complex because glycinato is -1, so the total negative charge is -3. This is +3. So this will be tris or triglycinato cobalt 3. Triglycinato or tris-glycinato cobalt 3. You can have also tri. Now this monodentate ligands again has got 5 GIs. And out of that, one of them, which is called cis, exists as a DL pair. So 5 plus 1, 6. I'll tell you how you visualize 6 in so many different ways. One of the ways all cis, AA cis, BB cis, CC cis. This is called cis. Now you change this. This is cis, all cis. Just make the last one cis and draw cis trans. So if it is possible to make C trans, try the possibilities. To make CC trans, you are left with choices. Can you make AA cis? Yes, you can make AA cis, BB cis. So AA cis, BB cis, but CC trans. So this is cis trans. The first cis is for A, second cis or trans is for B, the third cis or trans for C. Now let us make this first trans. Can you make it trans cis? So first let us make AA trans. Can you make BB? Yes, BB can be made cis, CC can be made cis. Yes, this is possible. Then let us make the middle one trans, cis, trans, cis. These are non-superimposable forms. So if you ponder more over it, show me how they are non-superimposable. Then you do the model and realize of your own. If you are unable to, uh, reconcile, you just take my words and make it. And remember them. They are non-superimposable, but all are symmetrical except the cis, which will lose any kind of element of symmetry, I, sigma, Sn. So that you verify. If you want to spend more time, you can do that. So cis, is it possible to make BB trans and CC? Yes, it is possible. So how many gone? 5. Then we have trans, trans, trans. Is it possible? Very much possible. AA trans, BB trans, CC trans. But what else we left? Trans, trans, cis we have not done. Let us see if this is possible or not. It is impossible. Trans, trans, cis. It is impossible. You will find that after you make two trans, AA, BB, you cannot have the CC to remain in the cis position. This is not a possibility. What else we have not done? Have we done cis, cis, trans? Oh, you have done. Then cis, trans, trans, have you done? Cis, trans, trans. Have you done?
Not possible.
Cis,
Not
then
possible.
trans, trans. That is also not possible. Supposing AA trans, BB trans, CC trans, not possible. So only possible are the 5 ones, out of which this is chiral, others are achiral. Only this is chiral. Let us not waste our time. And then we will make a list in that table, making M. Then that table you write M, A2, B2, C2, and number of GIs is 5. Need not write nothing. We have visualized it is 5 means 5 plus 1. You can just mention cis here is equal to 6. And then we go to the other type. You can also, I have no time, it is already 6:05. There is another way I was telling you, hinting you yesterday from A, M, A, B, C, D, E, F. You find all the 15 and then try to reduce. There will be repetitions. You cancel, you will find 5 for this type. And the next one comes MA2CD. What is the number? 13. Is it 13?
Yes, sir.
Yes, sir.
M A2B2 instead of C2, there is a 4th type of ligand D. This will be having 6 GIs, out of which 2 are chiral. So we will find it. So we will simply not draw the structures. It will be very time consuming. I will show you A, B, C, D, E, F later. So in the box, you write down M, A2, B2, CD type. Not type, type is already written in the top. Then here it is 6, here it is 2, total is 8. Then 13 is M, A2, B, C, D, E. M, A2, then B, C, D, E. There are 5 different ligands, but 2 of which are same. M, A2, B, C, D, E type. This will have ZIs, diastereomers will be 9, out of which 6 are chiral. So it will be 15. Write down once again in the table A2, B, C, D, E. Sorry, this is 9. So out of which 6 remain in chiral. So plus additional 6, with total will be 15. Finally, this 14 type is M, A, B, C, D, E, F type. Now, this will have 15 GIs and each of them is chiral. Each of them is disymmetric and chiral. So 15 plus 15, 30. So make in the table M, A, B, C, D, E, F. You let 15 here, 15 here, 30 here. Right? So it is 6:08. Good morning, everyone watching from the YouTube channel. We will be doing all the points in a very, very vigorous way. Therefore, those, I was really wondering, I was telling, I forgot to complete it, that why many guys from Odisha, they are not getting into a National Science Olympiad, at least National Science Olympiad. What to speak of International Science Olympiad? Because two things. Proper coaching is not there. Coaching is for only professional commercial things, not for the scientific and real talent hunting things. And if there is a possibility of coaching, many guys, they are not prepared. I mean, mentally not prepared. They are so much spoon fed both by their parents and their teachers in school, in coachings, and they are not interested to study anything more than what is required. So, to hunt the talent from the entire state, for me, has been a stupendous task. Hope against hope we are doing. But still, our journey is on. We are not discouraged. Now, let me tell you the Bayler's method. What is Bayler's method? Mathematical method, how we get 15 and then everything can be reduced. Supposing we make groups of 2, AA, BB, no, let us start 15, AB a group, CD a group, EF a group, AB, CD, EF. So these are opposites. When I write inside parenthesis, they are really staying opposite to each other. So we will be doing different, this is one, and from this we take MAB. Then interchange. It can be CE, it can be DF. This is the other. Keeping AB fixed, we can have other. It can be CF, it can be DE. CF, we have done CD, CE, CF, DE. So, what more you can do? Let us.
सर
Let
FB
us.
को चेंज करो
What?
सर
What?
FB से तो चेंज करो
Now let us fix CD. Keeping CD fixed, let us interchange between A, B, E, F. We'll get 3. That is A, E, and B, F. And then
AFB.
A, F, F,
BE.
and what more?
BE.
Hmm? What more you can do? You have to get 3 on each.
Sir, ABEF.
A, B, and EF. Yes. Keeping CD fixed, A, B we have not done. Then EF. A, B.
Here the fast case ହେଇଗଲା.
ଏଇଟା ପ୍ରଥମ
First case.
First case. Yes. What else we can do? I have done this to save time. Let me show you what I have done here. I have done myself A, B, C, D, E, F. A, B. The first one is A, B, C, D, E, F. Then 2 more we have done. Oh, I'm so sorry. We have to make AC fixed, which we have not done here. We have to make A as the beginner. A remains always the fixed. We now make fixed SC. So once we make AC fixed, then this BDEF1, then BEDF1, then BFDE the other. Then AD, then AE, then AF. Let us do that. Oh, I brought the same thing. No. Combination should be different. So let us make AC, this combination of AC that is fixed, and the remaining BE and DF we make changes. It will be how much? What? B, what? BD, EF.
EF.
A, B, C, D, E, F. And then keeping AC fixed, what else we can do?
BFED.
BEDF.
EE and DF. What else we can do?
BFDE.
BFDE.
EF and DE. B, E, D. Okay? So how many we create?
6.
3.
6.
And then again change. Keeping A fixed, AB, AC, AD fixed. Then among the 4, what? It will be, we are left with C, B, C, E, F. So make grouping, BC opposite, EF opposite. We can, keeping AD constant, we can have BE opposite, CF opposite. Keeping AD constant, we can have what?
BF opposite and CE opposite.
BF opposite and CE opposite. So in this also we get 3. And similarly, we will get making M, A, E fixed. Then we get 3. You write down at home, you get 3. So how many 3's have come? 3 plus 3 plus 3 plus 3. And then finally, M, A, F remaining fixed. We get again 3. So 5 threes, 1, 2, 3, 4, 5. So it's 15. But once it is reduced, supposing we make it M, A2, B2, CD. Sorry. Slowly we shall go on in the upward direction. So instead of A, B, C, D, E, F, we make it A, B, C, D. No. Make A2. We shall leave B for 2 A's. Then start from C, D, E, F. That we have done in our A2, C, D, E, F. We have done here. A2, C, B, C, D. Sorry, A2, B, C, D. But we are deliberately making A2, C, D, E, F. So B we have left for because there are two A, we have left B. So in the same, wherever there will be B, you put A. Wherever there will be B, put A. There will be repetitions. You will be finding nine geometrical forms. And then drawing the structures, applying your knowledge about symmetry, you will isolate 6 of them are dissymmetric and 4 are symmetric. So 9 plus 6, 15. Similarly, start reducing it AM, A2, B2, CD, make it then M, A2, B2, instead of B2, we write C2. Then instead of D2, because CD we leave in, then A2, B2, CD. So it will be A2, C2, then tell me what I will write. What I will write? Another C we leave for D. Then what we shall write?
EF.
EF. So write wherever in the main 15, for B you write A, for D you write C, and EF, EF, okay. Only for B, wherever you find B, write A, wherever you find D, you write C. So that you will be reducing to how many forms? 6, out of which 2 will be chiral, the other 4 will be achiral. So in this way, you come to A2, B2, C2, you will find actually you will make it A2, C2, E2. A2, C2, E2, leaving the middle ones for repetition, and then you will find the only possibility will be 5, out of which you draw them and see one of them, as we call cis, will be having dissymmetric and exists as a DL pair. So we will be closing today's session without now see how many others that I have to do in geometrical isomerism, because we are simultaneously studying geometrical and optical. This is the main file that I will send you today, which I have already done MAA, A2, BC, 2 cis, 2 trans, and this we have done. And we have to confirm this at home. You try to find any element of symmetry out of the 3 elements of symmetry. Why we will declare this as achiral. If you don't find, you make a model and show me where is the element of symmetry. If not, I will withdraw, I will modify, I will say this was wrongly stated and this will be really chiral. It exists as a DL pair. To err is human, to rectify is human. I am not the one who will try to persuade whatever comes to my mouth. I will see that that is prevailed. It's not like that. Knowledge is a vast ocean. And everyone, even me, at my fag end of my life, I mean career, uh, will be going to complete 68 years, will be 69 in maybe a couple of, I mean, a few days. I am reading every day, and every year is my improvement year. What I was teaching to my son, who was an IITian in the first chance, having a very high position, 500 some odd, and now I am teaching 100 times, maybe 100 times more than what I was teaching way back in 1998, 96 to 98, when he was my +2 student in Ravensa college. At that time, it was college, now university. The junior college has been segregated. I mean, so-called Ravensa Higher Secondary School, and some people are very, desperately trying to change its name from Ravensa to something else. Politics is going on. I am not. People are asking my opinion. I am deliberately not entering into the controversy. That is a controversial subject. Why shall I put my opinion? So never ever give any opinion when you find it is a political subject, it is a controversial subject. You remain diplomatically silent. And we have seen this M, A, B whole 3, A to B to C 2. I've drawn all this. Then it will be difficult to draw. It will be very time consuming. But table will be having the exact figure. 6 plus 2, 8. 2. 9 plus 6, 15. A, B, C, D, 15. All of them. Then tomorrow we'll be taking up this few only for table sake. And then I have a question for you. How many isomers the follow? Isomers that will include the structural isomerism. Following complexes have. Since bromide ion is a negative ion, chloride ion is a negative ion. So this chloride can come here outside. It will be Br2 inside. So this can be an ionization isomerism it can show. There is no hydrate. Had it been water ligand, then we could have made a hydrate isomerism. So one structural isomerism. And since it is A4 BC type, A4 BC is like A4 B2, only cis and trans geometrical isomers. So 2 plus 1, 3.
So F for B to C.
A4, A4, A2, small a. When I say a small, A4, small a4 and B2, small B2, or A4 BC. Two different ligands, same.
Yes, sir.
Trans.
Yes.
So there is no optical isomer. So one geometrical isomer, and each geometrical, one structural isomer, that is ionization isomer, and each ionization isomer will have two geometrical isomers, because it will be either A2 type or A4 BC type or A4 B2 type. Each of them shows cis and trans. So altogether there will be 4. Bromide remaining outside the coordination sphere, 2. Bromide remaining inside the coordination sphere, also 2. 4. So this type of question you may get. And since nitride and nitride both are there, this will not go, but bromide ion can go outside. Similar type. Bromide ion can go outside, and NO2 can come here, make it 2. Same type, A4B2 or A4BC. So this is similar to the second one. So, oh, no. This will additionally form a linkage isomerism here. NO2 can be written as ONO. So it will show linkage isomerism if you just change the donor from N to O, and it can also show ionization isomerism. If you take NO2 inside, it will be a complicated one. In fact, I devised this question only for linkage, because if there will be 2 NO2, one NO2 can be a nitrogen donor, nitrite ON, the other one can be oxygen donor. So it will be really complicated. So I will be withdrawing this question to avoid complicacy, right? So with this, I had a strong feeling that we'll be doing optical isomerism, but we have done 80% of optical isomerism is done. Tomorrow, maybe the last day before we take a break. Tomorrow is what day? Tomorrow is 5th. Yes, that will be the last day before we take a break, and we'll be resuming. Those who are watching from YouTube, for them, there will be tomorrow. There will be the end of stereoisomerism. We'll be also finalizing this one, which possibly we failed to demonstrate that there is a chiral, there is a symmetry element here. This one, particularly this one, we are yet to, which one? AA, 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 A3B, this one. this one, fac and mer, that this has somewhere element of symmetry. If there is no element of symmetry, then we have to declare this exists as a DL. But I think we will find a plane of symmetry. Yes. Yes. I am not able to hear you.
Sir, SN type रे SN.
Which one?
Sir, SN type रे SN.
SN.
Yes, sir.
Well, SN if we fail I or sigma, we can think of SN. That is,
Yes,
first
sir.
you have to rotate by a C2 or C3 or C4 CN axis. Then you have to take a reflection about a perpendicular plane and then compare. If the two are superimposable, the two forms, then there is an SN axis. So that we will check. Right? So that's all for today. And junior gamer Prakhar. Hello, sir. Hello, junior gamer Prakhar. So, and Anupriya Kumari. Hello. So we'll meet tomorrow morning, the same time. Bye-bye.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Bye. Hey, tomorrow